Hello, this is a quick third part out of three to walk us through item number 16.11. And this one's going to focus mainly on Excel. So this is a good one to have, just realizing from here on out through this course also too, where most of the items we're going to select in the text will not need a lot of hand crunch work, if you will. So what we're looking to do here is take the table that the textbook produced in 16.11. I put it here in Excel, and again, I walked through how to go to data analysis, and it's a single factor ANOVA. Later in this course, we're going to deal with the two-factor with replication. Um, but for now, what I did was I ran that ANOVA. It produced this set of data where it gave a summary of the different groups. Again, there were 5 different groups. Each one of them had 5 items in each. This gave us the average of each of those 5 categories, as well as the variance of each of those. And down here, this produced the table that the textbook actually was walking us through also and wanted us to produce, um, which was, again, you had the source of the variance, you have between, within, and total, the sum of the squares for each of those categories, the degrees of freedom, the mean standard error for each of these, and then these were the two values again that divide. This is the ratio that produces the F statistic. And then Excel does a nice job of then, it does give us a p-value and a critical F. This was based on an alpha of 0.05, which I left um, within here, where it's established right there in 0.05. Um, and that produced this. So we can use this first off to make that determination that yes, based on either an alpha of 0.05 or 0.01, we were able to reject the null hypothesis and say that these values are not equal in these different categories. Then the next step was, in parts B and C in our text, was to find the eta squared value. That gave us the effect size for the whole table. And if you notice, the values needed, which was the sum of the squares between divided by the sum of the squares of the total, are given right here. So I paired these up in blue. So these are the two values needed to find that score, which was again the effect size, or eta squared it's called. And then again, due to the fact that this p-value allowed us to reject the null hypothesis, we then go through and conduct Tukey's HSD test to pinpoint exactly which one of these sets or pairs uh, can we say produced a significant difference. And this part here, the Excel does not do that for us, but I calculated this using the formula within, or produced a formula for it. This Q score, if you recall, we actually find from the table, I think it's table G in the back of the book. And then we multiply that to, and you'll see up here, it was the square root of, um, this is the mean standard error for within of 19.42 divided by the sample size of each of these. And each one of these had a sample size of 5. If they are different, like they are in one of the other items, then we just find the average of those sample sizes, and that's our denominator there. And what we do then is we compare this 8.34 to the differences that we can have from the different pairings. And in the earlier screencast, I walked through how to do this by hand, but you can see that, for example, 14.8 minus 3 gives us 11.8, which is greater than this value of 8.34. So we can say that the groups of 0 and 6, there's a statistically significant difference, and so on. So hopefully this helps realize how you can use Excel so you can avoid having to do all the number crunching here and here. But I did think it was valuable to walk through this at least once, even if you used Excel to do it, to see actually what's going on behind the scenes. But from here on out, let's let Excel do the dirty work for us. And hopefully this screencast helps you realize how you can do that and answer the questions. Again, um, run that actual ANOVA test, and we can use this p-value to compare to our alpha or our level of significance and whether or not we reject or retain the null hypothesis. If we retain the null hypothesis, that means there isn't enough data to show that there's a difference between any of them. So we don't go any further, and that's it. But if there is a significant difference in our ANOVA test, then we continue on and find out um, what that effect size was for, or eta squared, and then we also then run Tukey's HSD. And hopefully that helped. Thank you.